Okay, so we're going to look at exponential models, and we're going to build a model of Snapchat users, monthly Snapchat user, since their beginning up until the end of 2013. And we're going to do it two different methods. The first method we're going to look at is we're going to utilize the idea that each time we move from one value to the next, we're always multiplying by a constant ratio each time. So each time I must move over. Okay, but if I look at this, if I'm careful here, I have to recognize that there should be a 1 there. So really, there's a 1 that's missing. There's a value in here that is missing, and a value 3 that is missing here. So I have to consider that when I go from 4.1 to the mystery number, that's times b. When I go to the mystery number to 6.3, that is also b. And so really I'm going to 4.1 times b is equal to 6.3. So b squared, and then 4.1, I'm going to divide it over 4.1. And then I'm going to take the square root of b, 6.3 over 4.1. And also recognize that if we remember, 6.3 over 4.1 is the same as going to the power of 0.5, or 1/2. And I can do this calculation here. But then I'm going to do it again. I'm going to go, well, from 6.3 times b again to get 8. And then times b again to get 14, and so on and so forth. I'm going to do the same repetitive calculation. So in order for me to do this calculation, well, I'm going to use a spreadsheet and try and do it in a fairly efficient manner. And so what I'm going to do is I'm going to use my spreadsheet. And to use a spreadsheet, I go equal to, and I know it's 6.3. It's 6.3 divided by 4.1. So 6.3 divided by 4.1. I'll put it in parentheses. I'm going to click on the cell B4, divide by B3, close my parentheses, put it to the power of 0.5, and I get 1.24. I'd already changed the decimal places so it's easier to read. But if I look at it, I could make them bigger if I wanted to, but when I have so many decimal places, it's actually hard to read what's going on. So I like to put it down to about 2. And so then I want to do it again here. I want to go equal to 8 divided by the 6.3, again to the power of 0.5, because I know there were 2 b's that had to be multiplied by, and I hit enter again. Now that would be long and tedious. There's a trick I can do. There's 2 of them. You see how there's a little blue square here? If you notice, my cursor changes from an arrow to a plus sign. If I double click on that plus sign, or that, it will do all the calculations. So this is going to be 32 divided by 24, which is what this says up here. So here are all the calculations for me done quickly, and then I'm just going to find the average. I'm going to find the average of C3 to C9, all these values in the orange square. Enter, and so my average is 1.19. And so my average B value, the average B, is equal to 1.19. And I remember that y is equal to a times b to the x is my plus c. And I haven't talked about c yet, and c for this case is going to be 0 because it's the horizontal asymptote. And if I consider here, I know eventually there were no Snapchat users eventually over here. And so I know it will never pass 0. So c is going to be 0. B I just calculated as 1.19. And then let's use t is time. A, well, I know when I'm telling you now that a plus c together, these equal to the y-intercept. Okay, the starting value. And so my starting value, my y-intercept here, will be 4.1. And so my a in this case is 4.1. And we're going to call this user, so let's call it m is a function of t. Millions of users is a function of t. 4.1 times 1.9. If I go over to Desmos, I have the data here. If I type it in, y equals 4.1 times 1.19 to the power of x. And you can see how it fits quite nicely. So this was the first method of modeling. And it utilizes the idea that each time I multiply by a factor. Okay, and we get that calculation. That's a method you should be familiar with. But there's a second method as well. The second method uses the idea that y is equal to a times b to the power x plus c. Okay, and again, we're going to make c 0 because we're just doing the basics right now. So c is 0. And the second method utilizes this equation. Y is equal to a times b to the x. And I plug in my next point. Well, 6.3 is my y. My a is 4.1. My b I do not know. I'm going to find b to the power of 2. So I divide by 6.3 times 4.1 is equal to b squared, and b will be the square root of 6.3 over 4.1, which was the same calculation before, obtained a different way. And I know that's going to be 1.24 if my memory is correct. But let's try it for this one now. Okay, so now when I go to the next value, I know y is 8 times 4.1, b to the power of 4. And so now I'm going to solve for b. I'm going to divide by 4.1 is equal to b to the fourth. And then I'm going to raise it to the 1/4, take the fourth root. And so b now is equal to 8 over 4.1 to the power of 1 over 4. And this will be, well, let's have our spreadsheet do it. Okay, so when I go to my spreadsheet, let me move this table over. When I go to my spreadsheet here, I know I need to make an equation to make this work. Okay, if I'm going to make an equation, I recognize that this is a fixed value. But what did I do? I took this cell and I divided it by 4.1, so 8. So if I do it with this row, I'm going to say is equal to, and I'll open the parenthesis, 8 divided by 4.1, which is my starting value. But I now need to make it to the power. How did I get this 1/4? Well, that comes from here, and that was my x value. So it's 1 divided by the x value. So it's 1 divided by the x value. And so that will work out, that will calculate the b value. And if I do the same thing for this one, I do the same thing all the way down, and I can do the same thing all the way up. Oh, I don't want to divide by 0. These numbers are too hard to read as they are, so let's make the decimals smaller. Here are the averages here. And so now if I find the average of these, I get 121. And so from this particular method, and granted this is modeling, it's not going to be exact values, I get y is equal to 4.1 times 1.21 to the power of x. It's similar, but it's a little bit different than method 1, where we got 1.19. So if we go now to our model here, let's try this one. Y equals 4.1 times 1.21 to the power of x. And when I look at that one, I get this one here. And so it also models it as well. And so sometimes you can see one looks better. And if I do this, I think the black one in this case looks better than the red one just by eyeballing it. We could also get Desmos to do it. And if I do Desmos, I'm going to go y1, and I'm going to do this tilde sign, that squiggle, 4.1, and I'm going to go b. I want to know what b is, to the power of x1. And when I do this one, Desmos does it with fancier calculations. I get 1.19049 as its b value. It likes this one better. But the key here is there's two different ways, at least two different ways, to model our function. We can use the power of the exponential equation, or we can use the power of the fact that exponential is constantly multiplied by a certain value. Both methods are reasonable to use because we're trying to find a model that fits. Once you've done them both, you can choose which one seems to appear better